Okay, so I did a little bit of work ahead of time to try to make this video as short as possible for you, so it's not a huge file. Also, sorry for the handwriting. Sine of x is here, right? And you had asked about the inverse sine of x, and I wanted to make a point here of why the domain for the inverse sine of x is what it is. So the inverse of any function is basically the reverse of the function. So in this case, we have sine of x, periodic, goes forever in either direction. The domain, so basically what we can put into sine of x, is all real numbers from negative infinity to infinity. And it always oscillates between 1 and negative 1. The inverse, however, if we wanted to, say, find out, well, let's look at sine of x here first. Sine of x, if we put in pi over 2 sine of x is 1, y equals 1, right? If we wanted to figure out what gives us 1 in the sine function, we'd use the inverse sine. So inverse sine, and I've flipped the variables here to try to make it a little bit more clear. If we were given a y and we want to find that x, we put 1 in here, and that gives us pi over 2, but we have a problem. What happens to this point here? This is also 1. That's 1. So is that. We have 3 pi over 2, negative 3 pi over 2. If we tried putting a 1 in here, we'd have multiple answers, and the problem with that is it's not a function. It's no longer a function. We have the horizontal line test here, right? So it can only pass the line once. So what we do instead is we restrict what we can actually put into it. And so if we take the sine of x function and we restrict it from pi over 2 to negative pi over 2, we have negative 1 to 1, and we only care about this right in here. So if we were to graph y equals inverse sine of x, this is what we get. Negative 1 to 1, and it gives us negative pi over 2 to pi over 2. So the domain is negative 1 to 1. We can only put in values from negative 1 to 1, and its output range is negative pi over 2 to pi over 2. Okay. So you asked specifically how to find the domain for inverse sine of x squared minus 1. Well, we know the domain of inverse sine of x, and if you're more familiar with the term arc sine, it's the same thing. Inverse sine or arc sine, that's negative 1 to 1. So the domain of this is whatever makes this inside of those parentheses equal to negative 1 to 1. So what we do is we take that bit inside, set it equal to negative 1, set it equal to 1, and solve for it. So here we have, we're going to move this one over here, and these cancel out. And then we have x squared is equal to 0, square root of 0, that 0, 0. So I put negative 0 and plus 0 here because whenever you have a square root, your result is a plus or minus, right? Because when you square something like negative 1 times negative 1, it always comes out to a positive. So over here, we have same thing, 2 equals x squared, square root of 2. These square roots and squares cancel. So you have x is equal to positive square root of 2, and as x is equal to negative square root of 2. Now these two here encompass this, so this is invalid. It doesn't really matter. That's kind of an artifact of a 0 point. But over here we have positive square root of 2 and negative square root of 2, and zeros in between the two. So our domain here is negative 2 to square root of 2. I will also go ahead and send you some screenshots from Wolfram Alpha that will help you out in solving stuff like this too. And I'll give you another link to a much more detailed paper. But that is how you solve that particular one.